Surfaces are used to represent an area of land on the Earth. They contain three-dimensional geometric data such as points, contours, breaklines, and boundaries. Once surface data is added to the surface is made up of triangles or grids, which are generated when Civil 3D connects the points that make up the surface data. The Prospector tab is where you manage surfaces that are in your drawing. If you look at the Prospector tab, there's a Surfaces category, and if you expand that, you will see what surfaces are available. To create a surface, you simply right-click on the Surfaces category and choose Create Surface. You can also get this from the Home tab, Create Ground Data, and then Surfaces dropdown. The surface definition is where the surface data will live. Note that this data is dynamically linked to whatever data was used to create the surface. This could be figures from a survey database, 3D break lines, 2D break lines, points, blocks, you name it. Whatever the data was that was used to create the surface will automatically update the surface once you rebuild it. If you look at the break lines category, you'll notice that I have some break lines that were created from the survey data. I also have a point group that was used to add the points from the existing ground topo. There are many ways to add surface data to a surface. The best way to add surface data, depending on the category of surface data, you simply right-click on it, and typically you'll have the Add option. As mentioned before, what's great about surfaces is that they are dynamically linked to the data that was used to bring them in. For instance, if I were to go ahead and change this survey break line, anything about the surface will update. The reason it's updating automatically is because there is an option to rebuild the surface automatically. To set that, right-click on the surface, and there's Rebuild Automatic. If you do not want that option, then you would toggle it off, like I have done so right now. So watch when I go ahead and pick this grip, and then change it back to the point. You will notice that a notification tells you that the surface is out of date, and you need to rebuild it. Simply right-click on the surface and select Rebuild, and automatically the surface will update. This concludes this video discussing an overview of surfaces. There are a few methods that you can use to establish breaklines in a surface. Breaklines instruct Civil 3D of points that have a linear relationship with each other, and two or more points are required to define a breakline. Let's examine how to create breaklines that could be added to a surface for proper triangulation, along with just creating some regular polylines that are used simply for graphical representation of a feature. First, let's use some point group functionality to minimize the clutter of points in our drawing. We want the point codes ditch, breakline, and wood lines to only appear so that we can see just those points. We'll go to the Prospector tab, Point Groups, and we already have a point group for breakline creation. Again, this is that point group that we would create in our drawing template so that for every drawing that we need to create breaklines for, we can just edit this and we'll use the No Display functionality to minimize that clutter. I'll right-click on 4 breakline points and go to Properties. And then in the Include, I'm going to make sure that with raw descriptions matching is toggled on. And then I'll just go into here and I can type them in. And we want ditch with an asterisk at the end of it in case there's any additional point information, so it'll grab all of them. BKL, asterisk, and WDL, asterisk. And then let's check our point list to verify that everything is there that we need to be. Again, this list is sortable, so you can sort by any of the columns and notice that we have the points that we need. Click OK. Now we need to set the priority for the No Display to be up top, and then for breakline creation to be above that one. Click OK. And sometimes you have to do a regen all, so I'm going to type in REA. And now we've minimized our point list. Note, if you want to zoom to the points in this point group, just right-click on it and choose Zoom To, and there are our points. Let's go ahead and change it to 1 inch equals 10 to just see the points a little bit bigger. So first, let's go ahead and create 2D polylines of the breakline, ditches, and wood lines, because eventually you can use those 2D polylines as proximity breaklines. This will be discussed in a future video. So I'm going to just use the polyline command. I'll type it in PL for polyline. And I also want to now initiate the transparent command for point object. Just to point out, if you want to actually turn on your transparent commands as a toolbar, you can go to the View tab, Toolbars, Civil, and then Transparent Commands. I'm going to type them in because it's a much more efficient method. So I'll just type in apostrophe PO, and that apostrophe says transparent command, PO is the one for point objects. Press enter, and then now just following the command line window, it says select point object. So I'll pick 1, 2, 3, and then I'm done. I hit escape. That puts me back into the polyline command, but I am done, so I can just hit escape again. So don't forget that. That's the process for using transparent commands. Simply invoke it, select the Civil 3D objects or functionality, hit escape to get you back to the original command, and then keep going. Let's go ahead now and create a ditch break line. So we notice that we, let's say, forgot the ditch figure prefix, but that's okay. We'll just go ahead and add it right here. So I know that by looking at these points, they're all in sequence except for up here. I have ditch 1 that ends at 797, and then as I peruse here, I notice that it does skip a point. So I can still use this functionality to do point objects, but it's also easier sometimes to actually type them in. So I'll start the polyline command again, but in this time, what I want to use is the point number transparent command, which is apostrophe PN, enter. And then now I can type in a sequence of points, and they can be separated by dashes and commas. So I want 791 dash 797, comma, 799 dash 804. Press enter, and just like that, as you can see, it just connects the dots for us. Again, when you're done with that transparent command, hit escape. Notice how it put you back in the original command that you started with, and just press escape again to get that done. Now let's go ahead and zoom around here, and we notice that here's our wood lines. So we actually don't need this. This is not going to be a break line. This is more for graphical representation. So what I'm going to make sure I do is I'll make sure that I set my layer to the correct layer, and it's v-topo-tree. And then I'll start the polyline command. And in this case, choose the point object. So apostrophe PO, press enter. And I'll just pick my points. Notice how you can do a crossing window if it makes it a little bit easier. If you mess up, hit escape and undo. Okay, so that was escape and undo if you mess up a vertice. And then simply just get back into the transparent command with apostrophe PO. Press enter or escape to get out of the transparent command, and then press escape to end the command. And that is it. So we now have some 2D polylines for graphical representation as well as for proper triangulation into a surface. Now, let's say I'm going to put all my points back up here. So I'll put the all points above everything. Click OK. Let's say the surveyors forgot to locate these points with the correct description. And in this instance, we actually have a head wall that we want to go in and create here that we will eventually use the head wall type break line. So you'll notice I have one point with head wall, and notice how the elevations are the same here. So I need these 3 points as the head wall. If you're going to do a head wall, you must have a 3D polyline. That way it can grab the actual elevations from the head wall object. So I'll just start the 3D polyline command, which is 3D poly. And then in this case, I could just use node snapping. So I have node snap already activated, and I will simply snap to the correct points. So that's 701, 798, and then 708. Hit escape, and now I've got my 3D polyline. I accidentally put it on the wrong layer, so I'll just select it and change it to the correct layer. So that's v-serve-figure. This concludes this video discussing creating break lines from points. Adding survey data to your surface is simply a matter of adding the break lines and points that were generated by the survey database and pointing to them by the surface. First, let's go ahead and create a surface. In the Prospector tab, in the Surfaces category, I'll right-click and select Create Surface. We'll call this surface EG. You can give it a description if you desire. And as with everything in Civil 3D, you must define a style for this Civil 3D object. So if I click this Browse button, you'll notice that these are the styles available in this drawing. We'll keep the contours, 1 foot and 5 foot background as our style. Select OK, and we now have a surface in our Prospector tab that is empty. We now need to fill it with the surface definitions of the break lines from the survey data, as well as the points from the survey data. So let's access our survey database by selecting the Survey tab, right-click on our Proj 1 that was created in the Import Events video, and select Open for Edit. Now I'm in a totally blank file, and I will simply right-click on Import Events and Insert into Drawing. This will insert all my break lines and all my points based on the import events that were defined here. Now I need to add the break lines in the survey database to my surface. And here's where the automation comes in. If you remember, in the Survey Figures video, we discussed how to automate break lines for surface creation. If I right-click on the Figures collection and choose Create Break Lines, you'll notice that a yes is toggled on next to the break lines based on their figure prefix in the figure prefix database. You still should scroll through your different break lines to actually see if all the break lines you want to be placed in the surface are correctly toggled on, or you need to toggle off some. Let's say I do not want the stone wall to be imported into the surface. So I'm going to toggle these off. And just like that, they will not be incorporated into the surface. Note that you can select the surface from here, as well as create a new surface if you need to from this icon right here. I'll click OK. You're prompted with the Add Break Lines dialog box. Notice how all the break lines are selected. And you definitely want to give these a description, such as break lines from survey data. And if you want to get even more detailed, perhaps what day you imported them and so on. There are some additional options here, which we will discuss when we talk about adding standard break lines to surfaces. But for now, we'll leave the default settings. Click OK. And we now have a surface just like that, created just from our break lines. Now we need to go in and add the points. Again, these survey points and figures are coming from the database. Should any of the information change in the survey database, we will be prompted to update and rebuild the surface. Let's navigate to the Prospector tab, and I already have a predefined point group that I can actually use to incorporate all the survey points that I want to add to my surface within the point group. Let's expand point groups. Notice how we have an out-of-date icon. So right-click on the point groups collection and select Update. Now all those point groups will incorporate the points based on their point group properties. So let's look at the points-EG point group properties by right-clicking on it and going to Properties. Within the Include tab, I now can see what points I will actually be adding into my surface. If you need to edit this, simply put a comma and add in the description that you want. Or you could include some points in the drawing by toggling the With Numbers Matching toggle on and select the Selection Set in Drawing button. We'll click OK. And now we need to add that point group as a definition in our surface. So let's go ahead and expand the definition category. Notice the definition categories we have available to us, and we want the point groups option. So, as I mentioned before, when in doubt, right-click on any interface component to get some different commands and options. I'll right-click on point groups and choose Add. Now I'll simply select the points-EG point group, click OK, and just like that, those points have been incorporated into the surface. Let's go ahead and look at our surface in 3D. Select the surface, and in the ribbon, there's the Object Viewer in the General Tools panel. Note, if you don't have a very good graphics card, this can take a while to rotate your view and display your surface. If you select an appropriate visual style, you can see your surface either in a wireframe or a shade of some type. I prefer shades of gray, as it shows you the surface in the best way. This concludes this video discussing adding survey data to a surface. Proximity break lines are 2D polylines that initially have an elevation of 0, and each point on the polyline, the X, Y, and Z, will be calculated based on the closest surface point. Now, if you already have existing survey points or a point file that you've used to import into the surface, then obviously it'll grab that X, Y, and Z. Before we add break lines to our surface, let's go ahead and turn the automatic update on in our surface. In the Prospector tab, Surfaces category, let's right-click on EG Surface and turn on Rebuild Automatic. That way, whenever we add break lines, we'll see the contours and triangles update automatically. First, let's go ahead and zoom into the 2D polylines that we created in the Creating Break Lines from Points video. So we first have this break line, just a standard old miscellaneous break line, and we'll expand the EG surface, expand the definition category, and right-click on the break lines category and select Add. It's always a good idea to give it a name, so I'll call this one Miscellaneous Break Lines, and change the type to proximity. I'll click OK and select the break line, and notice how the contours update automatically. Again, the points, the elevations, are coming from the closest surface point, which in this case is, of course, our surveyed points. Let's go ahead and add in the 2D ditch line that we created previously. So here's that ditch line right there. And I'm going to select it first, because you can do this either way. And I'm going to right-click on break lines and choose Add. And we'll call this one Ditch. Again, change your type to proximity, click OK, and notice how the contours update automatically. If you want to view your surface as you add and change surface data, you can actually select a few of these objects here, and your surface, and go to the multiple contextual ribbon and select Object Viewer. And notice how I can actually zoom in and start to see how my surface is coming along. Press Escape to get out of the Object Viewer and press Escape again to clear your selection set. So let's talk about standard break lines. So what are standard break lines? Standard break lines are 3D lines, such as 3D polylines or feature lines, where the XYZ coordinate of each vertex will be used in the actual surface. So you really do need to have the true elevation that you want to incorporate into your surface. Let's go ahead and add in some detention pond break lines that were located for us. We'll right-click on the break lines category again, select Add, and we'll call this one Detention Pond. Notice how I have done this individually. This allows you to organize your surface because you can then remove or turn on and off the different break line collections that you actually inserted into the surface. We'll leave the type set to standard, and because this is set to standard, you have a few options available to you. The two options are weeding factors and supplementing factors. And what do they mean? Weeding allows you to take out vertices based on a distance and an angle difference. So if you have too many vertices in a linear object, then you would want to actually take out some of those vertices if they're not necessary to be brought into the surface. This will make your surface a little bit smaller. Supplementing factors are very useful if, let's say, all you have is 2 or 3 points on a line and you want to actually increase the triangulation that occurs. So you can add in specific distances as well as a mid-ordinate distance for curves. The smaller the distance here, the more tight your triangles will be around curves. And that will actually help you with your triangulation. So I'm going to add in a distance of 5 and a mid-ordinate distance of 0.1. This will allow me to have nice tight triangles in the areas of the curves. I'll click OK, and I'll select the 2 break lines for this object. Hit Enter, and just like that, I now have my surface updated. Again, I could select all 3 objects, the surface and the 2 break lines. And if, let's say, I want to select even more to see what I've done here, I can select some of these objects as well as the break line, and right-click and go to Object Viewer. And this will allow you to see some of the updates to the surface. Selecting the break lines makes it easier to find the objects you want to see updated. Press Escape to exit Object Viewer and Escape to clear your selection set. This concludes this video discussing adding proximity and standard break lines to a surface. Headwall break lines are useful when you only have either the top or bottom northing-easting elevation of a feature, and either a consistent elevational difference between the points, or a measured distance at each vertex. This depth would, in most cases, come from the surveyor's notes. A few examples of using the headwall type break line are curbing, as long as there's a consistent depth for all points, or a concrete culvert where the top of the culvert was located and the depth of the bottom points would be measured in the field. So that's the example we have here. We have a concrete headwall that was located in the field, and we have depths to it. So, as mentioned in the Creating Break Lines from Points video, for a wall break line to be used, it must be a 3D polyline because the elevations are actually coming from the wall break line. So this is a 3D polyline, and we will use the depths based on the surveyor's notes to define the correct depth. To add a wall break line to your surface, navigate to your surface, and then in the break lines category, right-click and add. We'll call this one Concrete Culvert, and we'll change the type to Wall. Notice, if you would like, you do have the options to weed out or supplement your distances on the actual object. We'll click OK because we want to just use the vertices that were located, and we'll select our wall break line. Press Enter. So always look to your command line window when you don't know what to do. It says pick an offset side. So this is important because Civil 3D surfaces cannot triangulate right on top of each other. there will be a slight offset to this line, and it needs to know which direction to actually create the triangulation. So we want the wall to go down this way towards the ditch here. All you have to do is pick a direction. You don't have to snap to anything. So I'll just click over here. And then it says enter option for wall heights. If it's a consistent depth, just select all and then type in that depth. In this case, we have an individual depth. So we'll click on individual. This is new in 2013. You can select the individual or type I. Please make sure you look to the command line window for this next option. It says specify elevation for offset point at this location. Notice this little tiny white X appearing. And what it's saying right now is if I were to type in negative for the negative depth, it would actually go down to that depth. So you want to type in the delta or the change in depth from this elevation. Right now it's telling you this elevation is 101.54. So make sure you pick delta, because if you don't, it'll actually go down to the depth of that distance you type in. You are then prompted for the elevation. So based on the surveyor's notes, we are 0.5, let's say from here. And actually make sure you type in the correct positive or negative value. So I need to type in negative 0.5 because I'm going down a depth. If not, it would go up. Notice how the X is now at the 0.798. And in this case, we're down -1, enter. And now we're at the last one here, and this one here is -0.4, enter. And notice how our triangulation updates automatically because we have Rebuild Automatic turned on. If you would like to see what you've just added to the surface, select a few of the objects and the surface, and then right-click Object Viewer. And now you can see the additions you have in your surface. So there's the triangulation going straight down for the head wall. This concludes this video discussing adding a head wall break line to a surface. Civil 3D has the ability to use contour data to create a surface. Contour data can come from a variety of sources, for instance, USGS, aerial, etc. In our example, we had one side of the lake surveyed by another company, and they gave us contour data to add to a surface. Before we proceed, let's go ahead and isolate those layers so we can add them to a new surface, which we will eventually paste into our topo surface in a future video. In the Home tab, Layers panel, let's go ahead and use the Isolate Layers command, and they gave us the contour data on one layer. We'll select that layer, press enter, and there's our contours. So, as I mentioned before, we'll create a brand new surface that we'll eventually paste in with our existing ground. So right-click on the surfaces collection and choose Create Surface. And we'll call this one Surveyed Lake. We'll keep the description, we'll keep the style the same, and click OK. Now that we have our surface, we can expand the surface, go into its definition, and as we did with the break lines, simply right-click on Contours and select Add from the shortcut menu. We'll give this one a description as well. It's always a good idea to add a description along with the date that the survey was imported. So we have two options here. We have weeding factors and supplementing factors. So you can use weeding factors to reduce the number of points that will be generated along a contour, as contour data sometimes contains more vertices than is really necessary. The supplementing factor section will add vertices along a contour if you do not have enough vertices. Note, the weeding factor distance must be less than the supplementing factors for this to work properly. The Minimize Flat Areas section helps find and eliminate triangles where 3 points are at the same elevation and the edges that connect the points on different data contours are at the same elevation. This will reduce the number of flat areas and create a more realistic surface. I'll stick with the defaults and click OK. Now I need to select my contours, so I will make a crossing window like so. However, do not forget to unselect this border. This is simply a border object that is at elevation 0. So I'm going to hold down the Shift key on the keyboard, standard AutoCAD functionality, and unselect that border object. I'll press Enter, and now I have my contours. I simply need to unisolate my layers, and there is my surface. Again, as with everything in Civil 3D, it's very dynamic, so if anything should be wrong with the contours, or you need to adjust any of these contours, you can simply select it, and by using the grips, again you'll get the notification that tells you it's out of date. You can simply right-click on the surface and choose Rebuild. And just like that, you have your contour surface and your edits. This concludes this video discussing adding contours to a surface.